Have you ever wondered how a scale can tell how much you weigh, even without any batteries or buttons? Mechanical scales do this with simple parts and clever science. They have been used for many years in kitchens, shops, and bathrooms. Mechanical scales are reliable, easy to use, and can work anywhere. These scales use springs and levers to measure weight. There's no need for electronics. Just step on or hang something from them and let physics do the work. Inside, a spring stretches or squeezes, and a pointer moves to show your weight. It's honestly amazing how such simple machines can tell us so much. Understanding how they work helps us appreciate science in everyday life. Let's dive inside these fascinating devices and see what's really going on. By the end, you'll know how both hanging and floor scales work, what keeps them accurate, and how they use the same scientific ideas. A mechanical scale is a device that measures weight using physical parts, not electricity. Unlike digital scales, mechanical scales work anywhere, anytime. They use springs, levers, and gears to show the weight of an object or person. When you put weight on the scale, something inside moves. Usually it's a spring. This movement is linked to a pointer or dial that shows a number. That number is your weight. The heavier the object, the more the spring moves. All mechanical scales, big or small, follow this simple rule. They use the way springs stretch or compress to tell us how heavy something is. The secret is in how the spring reacts to force. Mechanical scales are used everywhere. From weighing produce at the market to checking your luggage at the airport, or just stepping on a bathroom scale at home. Hanging spring scales are often seen at markets or on fishing trips. Their design is simple and easy to see. At the top, there's a hook or loop for holding the scale. At the bottom, there's another hook for the item you want to weigh. Inside the scale, a strong metal spring connects the two hooks. Around the spring, there is a dial with numbers. These numbers show weight. There's also a pointer that moves as the spring stretches. That's how you read the weight. When you hang something from the bottom hook, gravity pulls it down. This force makes the spring stretch. The more weight, the longer the spring becomes. The pointer is connected to the spring, so it moves with the stretching. The dial is marked with weight units, like pounds or kilograms, to make reading easy. So what happens when you hang a bag of apples on the scale? The bag pulls down on the spring. The heavier the bag, the more force it uses. This extra force makes the spring stretch farther. As the spring stretches, it moves the pointer. The pointer slides across the dial, lining up with the correct weight number. If you add more apples, the spring stretches more and the pointer moves further. Take some away, and the spring goes back, moving the pointer to a smaller number. It's all about the balance between the pulling force, which is the weight, and the spring's resistance. Each spring is designed to stretch a certain amount for each unit of weight. This is what keeps the scale accurate. The spring is strong but flexible. It always tries to pull back to its original shape. This fight between force and spring is what makes the pointer move. The magic behind spring scales is Hooke's law. Named after scientist Robert Hooke, this law tells us how springs work. It says, the force needed to stretch or compress a spring is proportional to how far it moves. In math, it looks like this: F equals K times X. Let's break that down a bit. F is the force, K is the spring constant, which basically means how stiff the spring is, and X is how much the spring stretches. A tough spring, with a high K, needs more force to stretch even a little. On the other hand, a weak spring, with a low K, stretches more easily. For example, if a spring has K equal to 100 newtons per meter, and you hang a 2-kilogram weight, which is about 20 newtons, then X equals F divided by K. So that's 20 divided by 100, which gives 0.2 meters. The spring will stretch 20 centimeters. Hooke's law keeps the scale honest. As long as the spring stays in good shape, the dial numbers stay true. Bathroom scales look different, but inside they use springs too. When you step on the platform, your weight pushes down. Under the platform, there are several levers. These are flat metal bars that act kind of like seesaws. These levers spread your weight evenly across the scale. They connect to a strong central spring. Your weight doesn't push straight on the spring. Instead, it's distributed by the levers. This lets the scale measure even heavy weights with a small spring. The spring is hooked up to a system of gears and a dial. The more the spring is pressed, the more the gears turn. The pointer moves across the dial, showing your weight. Even though it looks simple from the outside, a lot of smart engineering happens inside a bathroom scale. Levers are key to making bathroom scales work well. When you step on the platform, your weight is not just pressing on one spot. The levers inside spread this force out. Think of a seesaw. When you push on one end, the other end moves too. In a bathroom scale, several levers connect at points under the platform. They transfer your weight to the central spring, but with less force than if you stood right on it. This lets a small, sensitive spring measure a big force, like your whole body weight. The levers also help keep the scale balanced. No matter where you step, the levers share out your weight evenly. This keeps the reading accurate, even if you stand on one foot. Sometimes the levers even magnify the force, making it easier for the spring and dial to feel small changes in weight. How does the movement of the spring become a number on the dial? That's where gears come in. In both hanging and bathroom scales, the spring is linked to a set of gears and a pointer. When the spring moves, it turns the gears. Each small movement of the spring moves the pointer a certain amount. The gears are carefully designed so that the dial numbers match the force on the spring. This makes reading your weight easy and smooth. If you step off, the spring relaxes and the gears turn back. The pointer returns to zero. If the gears or pointer get stuck, the scale may not read right. That's why smooth gears are important for accuracy. This clever mix of springs, levers, and gears turns invisible forces into simple numbers anyone can read. Mechanical scales need calibration to stay accurate. Calibration means setting the scale to show zero when empty. If the pointer is not at zero, your weight reading will be wrong. Most scales have a small wheel or screw to adjust the pointer. Over time, springs can stretch or wear out. If a spring loses its bounce, the scale may read too high or too low. That's why checking and calibrating your scale is important. It helps keep your weight readings true. Sometimes dust or old grease can make gears stick. Cleaning the scale or having it serviced can solve this problem. A well-cared-for scale will last for years. Calibration is the key to keeping your scale honest and reliable, year after year. Springs are tough, but only up to a point. Each spring has an elastic limit. This means the maximum amount it can stretch and still return to its original shape. If you put too much weight on the scale, the spring can stretch too far and get damaged. When a spring passes its elastic limit, it won't spring back all the way. The scale will start to read wrong, even after you take the weight off. The dial might not return to zero, or the readings might always be too low. That's why it's important not to overload your scale. Most scales have a maximum weight limit. Going over this can ruin the spring and the whole mechanism. A good spring, used properly, will work for many years. But once it's stretched too far, the only fix is to replace it. Hanging spring scales in floor or bathroom scales look different, but they use the same basic science. Both use a spring to measure how much force or weight is applied. Both follow Hooke's law. The force stretches or compresses the spring, and this movement is shown on a dial. The main difference is in their design. Hanging scales use a single spring that stretches when you hang something. The pointer moves as the spring stretches. Floor scales use levers to spread the force over a central spring, which is then connected to gears and a dial. Both types need calibration, and both must be protected from too much weight. If you treat them well, they'll give you accurate readings for a long time. Mechanical scales are simple, clever, and full of science. Next time you use one, you'll know exactly what's happening inside.